Imagine for a moment the universe as you have always known it. Stars burning in the dark, galaxies spiraling gracefully, planets tracing their silent orbits. Time, in this familiar cosmos, marched forward. It carries with it everything we have ever known, everything we will ever experience. The rise and fall of civilizations, the laughter of children, the fading of memories, the inevitable decay of all things. We assume it flows as it always has, a river that moves in one direction, unstoppable, unchangeable. Yet, what if this assumption, this very foundation of reality, were not as solid as it seems? What if the arrow of time, the progression from past to present to future, was not a constant, but a variable, a malleable dimension that could bend, twist, or even reverse? Imagine the disorienting possibility. Everything you know about cause and effect, every story you have ever lived, every memory you have ever held occurring in reverse. The coffee you spilled rewinds to the cup, laughter contracts into silence, and history itself folds back upon itself, layer by layer. This is not a mere flight of fancy. This is the question we will explore. From the smallest particles to the vast stretches of cosmic expanse, time is the thread that stitches reality together. Our lives are built on its forward momentum. Yet, physics, the science that strives to understand the universe at its deepest levels, whispers hints of possibilities far stranger than daily experience allows. In the quantum realm, causality, the principle that the past determines the future, sometimes falters. Particles behave in ways that seem to anticipate events yet to happen. A ghostly dance that suggests backward causation might not be as impossible as it appears. Meanwhile, the cosmos itself, stretching over billions of years, presents evidence of cycles and reversals on scales our senses cannot perceive. The universe has begun, and it may yet end. But within those vast stretches, could there be moments or regions where time flows contrary to our expectations? Now, step back from the microscales of atoms and the macroscales of galaxies and consider your own daily existence. Every morning, the sun rises. You drink your coffee, speak to a friend, perhaps touch the screen of a device, watching events unfold as you anticipate them. Time is invisible, yet omnipresent, guiding each thought, each action, each breath. But imagine these actions unraveling backward. The warmth of a cup retreats into the coldness of porcelain. Words draw themselves back into silence, and gestures of affection vanish before your eyes. What would it mean to live in such a world? What would memory become if it were not a linear sequence, but a backward projection? A film rewinding over and over. Could consciousness itself survive, adapt, or perceive reality differently when the arrow of time is inverted? Human history. Imagine for a moment the universe as you have always known it. Stars burning in the dark, galaxies spiraling gracefully, planets tracing their silent orbits. Time, in this familiar cosmos, marched forward. It carries with it everything we have ever known, everything we will ever experience. The rise and fall of civilizations, the laughter of children, the fading of memories, the inevitable decay of all things. We assume it flows as it always has, a river that moves in one direction, unstoppable, unchangeable. Yet, what if this assumption, this very foundation of reality, were not as solid as it seems? What if the arrow of time, the progression from past to present to future, was not a constant, but a variable, a malleable dimension that could bend, twist, or even reverse? Imagine the disorienting possibility. Everything you know about cause and effect, every story you have ever lived, every memory you have ever held occurring in reverse. The coffee you spilled rewinds to the cup, laughter contracts into silence, and history itself folds back upon itself, layer by layer. This is not a mere flight of fancy. This is the question we will explore. From the smallest particles to the vast stretches of cosmic expanse, Time is the thread that stitches reality together. Our lives are built on its forward momentum. Yet, physics, the science that strives to understand the universe at its deepest levels, whispers hints of possibilities far stranger than daily experience allows. In the quantum realm, causality, the principle that the past determines the future, sometimes falters. Particles behave in ways that seem to anticipate events yet to happen. A ghostly dance that suggests backward causation might not be as impossible as it appears. Meanwhile, the cosmos itself, stretching over billions of years, presents evidence of cycles and reversals on scales our senses cannot perceive. The universe has begun, and it may yet end. But within those vast stretches, could there be moments or regions where time flows contrary to our expectations? Now, step back from the microscales of atoms and the macroscales of galaxies and consider your own daily existence. Every morning, the sun rises. You drink your coffee, speak to a friend, perhaps touch the screen of a device, watching events unfold as you anticipate them. Time is invisible, yet omnipresent, guiding each thought, each action, each breath. But imagine these actions unraveling backward. The warmth of a cup retreats into the coldness of porcelain. Words draw themselves back into silence, and gestures of affection vanish before your eyes. What would it mean to live in such a world? What would memory become if it were not a linear sequence, but a backward projection, a film rewinding over and over? Could consciousness itself survive, adapt, or perceive reality differently when the arrow of time is inverted? Human history, too, is bound to the flow of time. Wars are fought, treaties signed, empires rise and crumble, all under the assumption that yesterday shapes today and today shapes tomorrow. But if time flowed backward, history itself would become a series of unevents. The construction of the pyramids would disassemble stone by stone. The rise of Rome would contract into villages, and our own biographies would regress toward the unformed potential of infancy. Every historical paradox we have struggled to reconcile, the chicken or the egg, cause and consequence, predator and prey, would gain a new dimension. In this reversed reality, questions we thought settled would demand answers once again, and the line between speculation and scientific possibility would blur. Philosophers have long pondered the nature of time. Aristotle described it as a measure of change, a sequence of nows strung together in a continuum. Kant insisted that time is a framework imposed by the human mind, structuring perception rather than existing independently. In both cases, time is intimately connected to experience, consciousness, and understanding. If time could flow backward, it would challenge not only the laws of physics, but the very foundations of thought. Could ethics persist if consequences preceded actions? Could memory retain meaning if the past were continually undone? What would it mean to choose freely when choices themselves are erased before they are made? These questions are no longer hypothetical. They are the thresholds of imagination and inquiry we are about to cross. Consider, for a moment, the paradoxes that emerge when we toy with the idea of reverse time. In physics, there is the concept of the block universe, where past, present, and future coexist in a four-dimensional space-time, immutable yet accessible in principle. If this is true, then our perception of time's forward flow is an illusion, a cognitive bias shaped by entropy, memory, and consciousness. Yet entropy itself, the second law of thermodynamics, seems to insist on a preferred direction. Ice melts, eggs break, stars age. Everything points forward. And yet, at the quantum level, probabilities allow for reversals, for events that appear to defy the unidirectional march of causality. The conflict between these scales, thermodynamic certainty and quantum ambiguity, is where speculation begins to converge with science, and where the cinematic story of our inquiry must take root in imagining backward time. We confront not only the universe's mechanics, but our own perceptual limitations. Could a single human mind track events that unfold in reverse, reconstructing experience as it disappears? What would emotion feel like when grief anticipates joy, or sorrow precedes loss? Could love itself persist when the sequence of giving and receiving is inverted? These questions hover at the intersection of physics and philosophy, blending the rigorous logic of science with the emotional depth of human experience. The narrative tension created by these contrasts, the familiar versus the impossible, the seen versus the speculated, forms the backbone of our exploration. To ground this in something tangible, let us return to everyday life. Picture a raindrop falling from a leaf. In normal time, it descends, gathers speed, and splashes onto the ground. In backward time, the drop leaps from the soil, climbs the stem, and reunites with the leaf, erasing the moment of impact. On larger scales, imagine civilizations unbuilding themselves, rivers retreating, mountains collapsing into valleys. The cinematic spectacle of a universe rewinding is not merely a visual curiosity, it is a lens through which we begin to question the assumptions we have taken for granted. By juxtaposing our familiar experience with the hypothetical reversal of all events, we engage the mind and emotions, priming ourselves for deeper inquiry into the mechanisms of time, the laws that govern reality, and the limits of human understanding. History, physics, consciousness, and speculation converge here. Our task is, but the certainty of Newtonian time was only the beginning. Centuries later, Albert Einstein shattered this illusion with his theory of relativity, revealing that time is not universal, not absolute, but interwoven with space into a dynamic fabric space-time. Suddenly, the ticking of clocks was no longer identical across the cosmos. Near a massive object, time slows. Approaching the speed of light, time stretches, dilates, and bends. The arrow of time, previously unquestioned, becomes a relative experience dependent on one's frame of reference. Two observers may witness the same event, yet perceive its timing differently. The universe, once imagined as a uniform clock, now reveals itself as an intricate tapestry, each thread representing a different temporal experience. Science, it seems, has shown us that time is both real and malleable, concrete and elusive, a paradox that invites both awe and confusion. Even within this relativistic framework, time maintains a preferred direction, guided by the inexorable increase of entropy, as codified in the second law of thermodynamics. Entropy, a measure of disorder, gives time its arrow. Ice melts, stars burn their fuel, galaxies collide and scatter matter into the void. The universe evolves from states of lower probability to higher probability, a progression that seems irreversible. Everyday experience confirms this law. Broken cups do not spontaneously reassemble. Spilled milk does not leap back into the glass. And yet, as we explore the microscopic realm, quantum mechanics begins to challenge this classical picture. At the scale of atoms and subatomic particles, the distinction between past and future blurs, and time's arrow becomes a suggestion rather than a decree. In quantum theory, the deterministic predictability of Newtonian mechanics gives way to probabilities and uncertainties. Electrons do not travel along fixed paths. They exist in superpositions, their future positions represented by probability waves. And in some interpretations, events in the future can influence measurements in the present, a phenomenon called retrocausality. Experiments like the quantum eraser suggest that particles decide their past behavior based on measurements taken afterward, raising questions that strike at the heart of linear time. How can a particle act in the past as if it knows the future? Is the flow of time an emergent phenomenon, a construct of human perception, rather than an absolute feature of reality? Here, the certainty of classical physics collides with the strangeness of quantum reality, a tension that invites both curiosity and unease. To bring these concepts closer to human intuition, consider the simple example of a melting ice cube. In classical thermodynamics, the ice absorbs heat from its surroundings. Molecules vibrate faster, and the structured crystal lattice collapses into liquid. The process is irreversible. The universe prefers disorder over order. But at the atomic level, every molecule obeys time-symmetric laws. Theoretically, if one could reverse the velocities of every molecule in the ice cube, it would reconstruct itself, returning to its frozen form. The forward flow of time, so obvious at our scale, is emergent, a statistical phenomenon arising from countless microscopic interactions. The arrow of time is not enforced by the laws of physics themselves, but by the overwhelming improbability of spontaneous reversal in macroscopic systems. This contrast between the microscopic and macroscopic is central to understanding how science frames time, and how speculation begins to creep in at the edges of certainty. Stars, too, provide a cosmic illustration of temporal flow. They are born from collapsing clouds of gas and dust, ignite in nuclear fusion, and eventually exhaust their fuel. Some explode as supernova, scattering heavy elements that seed new worlds. The narrative of stellar life appears unidirectional, a story of creation and decay. Yet, at the quantum level within the core of stars, nuclear particles engage in interactions that, in theory, could proceed backward with equal probability. Time, it seems, is layered. On large scales, entropy and thermodynamics dictate direction. On small scales, reversibility is a subtle, hidden property, suggesting that the universe's apparent linearity may be a macroscopic illusion. Einstein's equations of general relativity add another dimension to this picture. They predict the existence of closed time-like curves, paths through space-time that could theoretically loop back on themselves. A traveler along such a curve might revisit their own past, creating temporal paradoxes that have long been staples of science fiction, but which are mathematically permissible. Wormholes, solutions to Einstein's equations, tantalize with the possibility of shortcuts through space-time that could, in principle, connect different temporal points. While practical realization remains speculative, the mere fact that such solutions exist challenges our intuitive understanding of time as a one-way street. Science, once thought to be bound by linear chronology, now hints at pathways where time might bend, fold, or even reverse. Cause this with human experience. Our perception of time is intimately linked to memory and causality. We remember the past, but not the future. We anticipate events but do not experience them before they occur. This subjective arrow of time is reinforced by entropy. Memories form as neural connections stabilize. Information flows in one direction, and consciousness itself seems tethered to the forward march of events. If time were to reverse, our perception might collapse, leaving us unable to recognize cause and effect. The very fabric of cognition is bound to temporal directionality, making the hypothetical reversal of time not only a scientific curiosity, but an existential challenge. Consider the interplay of certainty and mystery, evidence and speculation. On one hand, thermodynamics, relativity, and classical mechanics provide robust, experimentally verified frameworks. They explain why ice melts, why stars age, and why human experience unfolds sequentially. On the other hand, quantum phenomena, relativistic anomalies, and cosmological theories hint at possibilities that challenge common sense. Could time flow backward in isolated systems? Could retrocausality be real? Could the arrow of time be different in regions of extreme gravity or near singularities? The boundary between science and speculation is porous here, inviting us to explore ideas that are both intellectually rigorous and profoundly unsettling. Historical thought experiments illustrate the tension. Consider Laplace's demon, a hypothetical intelligence that, Knowing the position and velocity of every particle in the universe could predict the future entirely. In a Newtonian framework, this demon could also reconstruct the past. Yet quantum uncertainty shatters this possibility, replacing determinism with probability. Science shows us that while macroscopic events are overwhelmingly likely to progress in one direction, microscopic interactions allow for ambiguity. The arrow of time is not absolute. It is emergent, statistical, and deeply intertwined with consciousness, perception, and entropy. Bringing these ideas together, we see that time is not a monolithic entity. It is a multi-layered phenomenon, experienced subjectively, governed statistically, and capable of surprising deviations from expectation. Classical physics provides a sturdy scaffold of predictability. Relativity stretches and warps our perception. Thermodynamics grounds us in the inexorable march toward disorder. And quantum mechanics whispers of possibilities that defy linearity. Within this intricate web, speculation emerges not as fanciful indulgence, but as a natural extension of inquiry, a necessary bridge between the known and the unknown. To further anchor these ideas, consider a cosmic analogy. Picture a galaxy forming over billions of years. Stars ignite, die, and seed new generations. Planets coalesce. Life emerges. The process appears linear, inevitable, and irreversible. Yet, at a subatomic level, each interaction is reversible. Each particle's path could, in principle, be traced backward, retracing every collision, every reaction. The grandeur of macroscopic irreversibility is built atop the subtle reversibility of the microscopic world, a layered reality that mirrors our journey from science to speculation. In the end, the scientific foundations of time provide both a map and a horizon. Newtonian mechanics gives us certainty. Relativity introduces relativity. Thermodynamics enforces directionality. Quantum mechanics introduces ambiguity. Together, they frame a universe that is both knowable and mysterious, a universe where the forward flow of time is dominant yet not absolute. For those willing to contemplate, the possibility of backward time is not merely science fiction. It is a question at the frontier of physics, a challenge to perception, and an invitation to wonder. As we transition from the concrete framework of physics into deeper exploration, the question emerges naturally. If the arrow of time is not absolute, if microscopic reversals are possible, and if the universe permits extraordinary anomalies, what might this imply about the nature of reality, consciousness, and our very understanding of existence? How do these scientific foundations prepare us to consider the audacious speculation that time itself might be flowing backward? The answers, or the questions, await in the next stage of our journey, where quantum mysteries, paradoxes, and the mind-bending potential of temporal reversibility come into focus. Here, science provides both anchor and launchpad. We now possess the framework to ask bigger questions, to contrast evidence with imagination, and to begin the cinematic odyssey into the universe's most profound enigmas. Forward motion, backward motion, certainty, and doubt, they converge as we step into the next chapter of inquiry, where the strange and the familiar collide, and the arrow of time may reveal secrets we have only begun to glimpse. At the heart of reality lies a realm that defies intuition, a world so strange that even the laws we consider absolute appear to waver. This is the quantum world, a microscopic universe where certainty dissolves into probability, where particles exist in multiple states simultaneously, and where the line between cause and effect becomes astonishingly ambiguous. In this domain, time is not a rigid arrow, but a pliable dimension, subject to anomalies that challenge the very foundations of logic and perception. It is here, at the frontier of physics, that we begin to glimpse a universe where effects might precede causes, and where backward time is not simply hypothetical, but a question open to experimental investigation. The journey begins with the double-slit experiment, a cornerstone of quantum mechanics. Picture a beam of electrons directed toward a barrier with two narrow slits. If observed, each electron passes through a single slit, forming a predictable pattern on the detector. Yet, if left unobserved, the electrons interfere with themselves, producing a wave-like interference pattern as if each particle simultaneously travels through both slits. Here, observation, the act of measurement, collapses possibilities into a single outcome, revealing a universe that responds to consciousness in a subtle, enigmatic dance. Science, in this context, confronts imagination. Is reality a fixed structure independent of observers, or is it shaped in part by perception? The double-slit experiment, simple in its apparatus, yet profound in implication, opens the door to questions that ripple through the very fabric of temporality. Take this one step further with the quantum eraser experiment, a variation that deepens the mystery. In this setup, particles pass through a similar double-slit apparatus, but detectors record which path information. Astonishingly, if the which path data is erased after the particles have already hit the detector, the interference pattern reappears as though the universe retroactively corrected itself. Cause and effect, which we have long taken for granted, no longer behave linearly. The future seems to influence the past, the act of observation reaching backward through time to shape events that have already occurred. It is a revelation that challenges every intuition grounded in classical physics, a cinematic tableau in which the past and future intertwine in ways that feel almost mystical. Entanglement adds another layer of intrigue. When two particles are entangled, their states are inextricably linked, regardless of the distance separating them. Measure one particle, and the other instantaneously reflects a complementary state. Albert Einstein famously derided this phenomenon as spooky action at a distance, yet repeated experiments confirm it unequivocally. If entangled particles respond instantaneously across light years of separation, the question of temporal ordering becomes ambiguous. Could one particle's present measurement influence the past state of its partner? Mainstream interpretations caution against overstatement, insisting that information cannot be transmitted faster than light. Yet the paradox persists. The entangled universe hints at a reality where events are not strictly sequential, where the temporal scaffolding of cause and effect may be more flexible than previously imagined. Now imagine the implications of retrocausality, the speculative idea that effects can precede causes. In a universe governed by retrocausal principles, a decision made today could influence outcomes in the past, a possibility that stretches both scientific and philosophical imagination. Some interpretations of quantum mechanics, such as the transactional interpretation, embrace this idea, positing waves traveling forward and backward through time to form events. Fringe though it may be, retrocausality forces us to reconsider the linear narrative of history, the sequential progression we rely on in daily life. Science, in this sense, becomes not only a method of prediction, but a lens for profound wonder, revealing paradoxes that exist at the boundary of knowledge and speculation. Consider a cinematic analogy, a ripple traveling across a pond. In classical physics, the disturbance spreads outward, predictable and measurable. In the quantum analogy, however, the ripple can appear to move backward, reshaping the very point where it began. This is not just poetic metaphor, it is the reality of experiments like delayed choice quantum erasers, which demonstrate that measurement and observation may influence prior states. Our assumptions about time's immutability confront empirical anomalies, inviting a narrative in which the past, present, and future are entangled in a delicate, almost poetic interplay. Yet these phenomena are not mere curiosities confined to laboratory tables. They hint at a universe in which determinism is limited, where linear causality is emergent rather than fundamental. Classical mechanics predicts outcomes with precision, because the scales involved are overwhelmingly large, averaging over countless quantum events. But at the foundational level, the world is probabilistic, and time's apparent flow may be a macroscopic artifact, an emergent property of entangled, uncertain interactions. Here, science and speculation converge. Quantum anomalies are rigorously measured, yet their implications about temporal direction, retrocausality, and the pliability of reality stretch into the philosophical and the cinematic. The paradoxes become even more striking when we confront the notion of superposition. A quantum particle does not inhabit a single state. It exists in multiple, simultaneous possibilities until observed. Schrodinger's famous thought experiment with a cat in a box illustrates this tension vividly. The cat is neither alive nor dead until the box is opened, a metaphorical bridge to the uncertainties of time itself. If the outcomes of events are probabilistic and contingent upon observation, then the sequence of cause and effect is not fixed. Could a future measurement choose the state of a particle in the past? Could reality itself be retroactively determined, its history rewritten moment by moment in a subtle, imperceptible quantum choreography? The implications for backward time are staggering. If the quantum realm permits, in principle, reversals of causal order, then the arrow of time we experience is emergent, contingent, and perhaps mutable. Science establishes the rules. Quantum mechanics reveals exceptions. Together, they frame a universe that is not a simple river flowing inexorably forward, but a multidimensional ocean of possibilities, currents, and countercurrents, in which past and future may intertwine in ways that defy linear comprehension. The cinematic potential of this view is undeniable. Reality itself becomes a theater of uncertainty, probability waves performing a ballet of cosmic ambiguity. In interpreting these experiments, mainstream physics often urges caution. No one has yet demonstrated macroscopic backward time or retrocausal influence in everyday experience. Classical intuition remains overwhelmingly reliable at human scales. But even so, quantum mechanics demands humility. It forces us to confront the limits of perception, the boundaries of causality, and the provisional nature of knowledge. Evidence and mystery coexist. The rigor of measurement and calculation stands alongside the strangeness of results that defy simple explanation. It is this tension, this interplay of certainty and ambiguity, that drives the cinematic narrative of quantum mysteries. Historical debates illuminate the stakes. Niels Bohr argued for a complementarity of wave and particle, a perspective embracing ambiguity and defying classical logic. Einstein resisted, seeking deterministic clarity. Schrödinger, Heisenberg, and Bell explored the consequences of entanglement and uncertainty, each experiment pushing the envelope of what is knowable. In these intellectual confrontations, science becomes a drama, a narrative unfolding at the intersection of empirical evidence and philosophical reflection. The cinematic quality of this history mirrors the experiments themselves. Strange, beautiful, and fraught with paradox. Consider the universe as a grand entangled system. Each particle, each photon, each quantum state forms a network of possibilities. When one element is observed, others respond in ways that suggest connections transcending conventional notions of time. The delayed choice and quantum eraser experiments are not isolated curiosities. They are glimpses of a reality where the sequence of events may be contingent, mutable, and interconnected. Here, causality is not a rigid framework, but a malleable tapestry, with threads stretching forward, backward, and sideways across a quantum landscape. This view invites speculation that borders on the philosophical. If time is not absolute at the quantum level, could macroscopic systems, entire events, histories, even civilizations exhibit analogous reversals under extreme or as yet unrealized conditions? Could consciousness, memory, or observation itself play a role in shaping not just the present but the past. While these ideas remain speculative, they emerge naturally from empirical observation, forming a bridge between rigorous science and profound philosophical inquiry. To visualize this, imagine a particle existing in two places simultaneously, its wave function collapsing only when observed. Now imagine the same principle applied, in theory, to larger systems, histories, decisions, or events existing in superposed states, their resolution contingent upon observation or interaction. Time, causality, and consequence become dynamic, malleable, and cinematic, challenging every assumption grounded in daily experience. Reality is no longer a linear narrative, but a multidimensional story unfolding simultaneously on multiple planes. Quantum paradoxes also highlight the limits of human intuition. The mind is accustomed to linear narratives, sequences of cause and effect that guide understanding and decision-making. Yet the quantum realm defies this comfort, revealing a universe in which the improbable can occur. The future can influence the past, and the familiar rules of temporal order dissolve. Here, awe and confusion coexist as we confront a reality both rigorously tested and profoundly mysterious. This is the cinematic power of quantum mechanics. It turns abstract mathematics into a narrative of wonder, curiosity, and existential reflection. Bridging to the next stage of our journey, these quantum revelations lay the foundation for deeper inquiry into the cosmos. If time's arrow is not absolute, if retrocausality is a real even if subtle effect, then the universe itself may contain regions, scales, or phenomena where temporal flow is nonlinear. Stars, galaxies, and perhaps even human consciousness might exist in a tapestry of time far more intricate than our everyday perception allows. We are prepared, now, to explore cosmic scale implications, where relativity, gravitation, and the evolution of the universe intersect with the quantum strangeness we have just witnessed. In sum, quantum mechanics challenges the very notion of linear time. Superposition, entanglement, and retrocausality invite us to consider a universe in which cause and effect are not fixed. Observation matters, and the past may not be immutable. Evidence and mystery coexist. Science and speculation intertwine. And the cinematic landscape of the universe unfolds before us in ways that are simultaneously beautiful, perplexing, and profoundly inspiring. It is a realm where backward time, once dismissed as impossible, becomes a legitimate, if enigmatic, frontier of inquiry. We leave the microscopic stage behind and ascend to the cosmic vista, carrying with us the knowledge that time, even in the vast theater of stars and galaxies, may harbor surprises that challenge linearity, defy expectation, and open pathways to mysteries previously unimagined. From the uncertain dance of particles to the grandeur of the universe itself, our exploration of temporal paradoxes has prepared us to confront the scale, scope, and spectacle of time on a cosmic level, where the laws of physics continue to intrigue, challenge, and inspire. To grasp the immensity of cosmic time is to confront the limits of human perception. Our lives are fleeting blips, measured in decades. Yet the universe stretches across billions of years, a scale so vast that comprehension falters. The cosmos began with a singular, explosive event, the Big Bang. In that first instant, space, time, and matter emerged together, a moment of creation so extreme that our conventional notions of before and after cease to hold meaning. Time, in a sense, began with this event. Yet even at this genesis, the universe hinted at complexity, paradox, and the potential for nonlinear temporality. The very fabric of reality expanded faster than light itself, a cosmic inflation that set the stage for galaxies, stars, planets, and eventually, consciousness. Consider the passage from the Big Bang to the first stars igniting in primordial gas clouds. Billions of years unfold in imperceptible increments. Gravity sculpts matter into whirling galaxies, while nuclear fusion and stellar cores generates the elements that will one day compose planets, oceans, and life. Each star lives and dies according to precise physical laws, yet on the cosmic scale, this process is far from uniform. Galaxies collide, stars explode in supernova, and black holes consume everything in their reach. Time on this scale is both measurable and inscrutable, its flow imperceptible, yet its consequence is immense. The contrast between human experience and cosmic time is stark. While we live moment to moment, the universe operates on scales that stretch the imagination, revealing a rhythm that is majestic, indifferent, and infinitely intricate. Black holes, the dark titans of the cosmos, offer a particularly striking lens into the nature of time. Within the event horizon, the known laws of physics bend toward extremes. Time, as measured from a distant observer, slows to a near standstill. A star collapsing into a singularity appears frozen, its final moments stretched toward eternity. Yet to an infalling observer, time continues normally, even as gravity intensifies. This duality, time frozen from one perspective, relentless from another, exemplifies the relative and context-dependent nature of temporality in the universe. In these extreme environments, the arrow of time is not straightforward. Causality may twist, loops may form, and the boundary between past, present, and future becomes fluid. Cosmologists speculate that black holes might even connect to other regions of spacetime, possibly forming wormholes. These hypothetical bridges suggest that the universe could host pathways where temporal flow is nonlinear. Events might loop or intersect, allowing for scenarios where cause and effect are not strictly sequential. While these ideas remain theoretical, they are grounded in Einstein's equations, which permit such solutions under extreme conditions. The implication is profound. The universe, on its grandest scales, may be far stranger than linear experience suggests. A cosmos where time is not simply a river flowing in one direction, but a landscape of currents, eddies, and loops yet to be fully understood. Galaxies themselves tell stories of time writ large. Spiral arms curl in majestic arcs, tracing the orbits of billions of stars over eons. Supermassive black holes anchor these stellar cities, warping space-time and influencing evolution across scales. Yet even as these processes unfold, the universe retains traces of its own past. Imprinted in the cosmic microwave background, the faint afterglow of the Big Bang. This radiation, uniform yet speckled with subtle fluctuations, is a map of time frozen billions of years ago. By studying it, astronomers reconstruct the universe's infancy, revealing a timeline that is both meticulously detailed and breathtakingly vast. The evidence is clear. Cosmic evolution is orderly, yet vast enough to render human perception almost meaningless in scale. Inflation, a rapid expansion that occurred in the universe's first fractions of a second, further complicates our understanding of temporal flow. Space itself stretched exponentially, separating points that were once infinitesimally close. Time and space, previously intertwined, expanded in concert, generating regions of the cosmos that may never interact again. In some models, this inflation gives rise to a multiverse, a collection of pocket universes, each with potentially different physical laws, timelines, and causal structures. Here, speculation brushes against evidence. Cosmic microwave background data and gravitational wave observations hint at inflationary processes. Yet the multiverse remains beyond direct detection. The contrast between measurable reality and theoretical possibility exemplifies the tension at the heart of cosmic temporality. Consider for a moment a collapsing star at the end of its life. As the core implodes, matter compresses to extraordinary densities. In the final moments before a supernova, time dilation becomes extreme. For a distant observer, the collapse may appear to stretch indefinitely, while inside, the process occurs in microseconds. Energy bursts outward, forming a shock wave that seeds the cosmos with heavier elements. In this act, the death of a star becomes both instantaneous and eternal, a paradox of cosmic temporality. Stars, in dying, create conditions for life, planets, and consciousness. The interplay of creation and destruction, of linearity and dilation, emphasizes that cosmic time is layered, contextual, and profoundly cinematic. Even the expansion of the universe itself hints at nonlinear temporal phenomena. Observations of distant galaxies reveal that space is stretching, carrying light with it and redshifting the fabric of reality. The farther we look, the further back in time we see. In essence, looking across cosmic distances is looking backward along the timeline of the universe. Photons emitted billions of years ago arrive at Earth now, offering snapshots of ancient events. This natural telescope allows humanity to experience cosmic history directly, yet the passage of billions of years remains abstract, almost incomprehensible. It is a reminder that the universe operates on scales vastly beyond our intuition, where the ordinary flow of seconds, minutes, and hours is insignificant compared to galactic lifetimes done in exploring time loops and multiverse scenarios. Speculation emerges naturally from these observations. If black holes and wormholes exist, if inflation generates multiple universes, then temporal structure may be far more flexible than our human experience suggests. Could events repeat in cycles across different regions? Could parallel timelines exist, where alternative outcomes unfold simultaneously? While evidence for such phenomena is currently indirect, theoretical frameworks provide mathematical plausibility. The tension between empirical certainty and speculative potential creates a cinematic tableau in which the universe is simultaneously knowable and mysterious, structured yet unpredictable. Cosmic time also challenges existential perception. Human life, bounded by decades, seems ephemeral against the backdrop of galactic rotation periods, stellar lifespans, and the universe's 13.8 billion year history. Our memory, history, and experience are fragile within this expanse. Yet, this contrast magnifies the grandeur of existence. Each conscious moment, each observation is a rare intersection with the vast continuum of time. By contemplating cosmic evolution, viewers are invited to experience awe, humility, and wonder. Time becomes not just a measurement, but a lens for existential reflection, emphasizing the beauty, complexity, and fragility of life within the vast theater of the cosmos. The concept of entropy further enriches this perspective. As galaxies evolve, stars burn fuel, and black holes evaporate via Hawking radiation. Disorder increases. The arrow of time manifests clearly on cosmic scales, mirroring the statistical principles observed in thermodynamics. Yet, quantum uncertainties and relativistic effects imply that microscopic exceptions may accumulate in extreme conditions, generating environments where linear causality is less rigid. Here, the cinematic tension is palpable. The universe is a narrative unfolding across eons, guided by laws, yet interspersed with moments of unpredictability and paradox. Evidence and mystery intertwine, producing a story as intellectually rigorous as it is emotionally compelling. Consider cosmic inflation once more. The exponential expansion not only set the initial conditions for galaxy formation, but may have created disconnected regions, other double universes, each with its own temporal evolution. In some speculative interpretations, these regions could interact or influence one another in subtle, non-linear ways. While observational evidence remains limited, the mathematical frameworks are compelling. The universe, in this view, is not a single timeline but a multidimensional ensemble, where time may flow differently in different regions. The implications are staggering. Linearity, causality, and temporal direction might not be universal but context-dependent, echoing the quantum phenomena we explored earlier. Visualizing cosmic time cinematically emphasizes scale and drama. Imagine a supernova exploding, its light traveling across millions of light years, reaching Earth long after the star has vanished. Galaxies spiral majestically, colliding and merging over billions of years. Black holes consume entire star systems, warping space and time. Inflation stretches space-time itself, separating regions of the cosmos beyond reach. These phenomena illustrate the contrast between imperceptible human experience and the grand, awe-inspiring sweep of cosmic evolution. The universe is both a laboratory of physical law and a theater of existential contemplation, where time operates as both a metric and a mystery. Evidence from astrophysics supports these narratives. Observations of cosmic microwave background radiation, gravitational lensing, and galaxy formation timelines provide measurable benchmarks for cosmic time. Yet each measurement also hints at deeper complexity. Anomalies in cosmic expansion, patterns in background radiation, and the behavior of matter under extreme conditions suggest layers of temporal subtlety that challenge simplistic, linear models. The universe reveals itself as both orderly and enigmatic, predictable in principle, yet astonishing in detail. It is a cinematic paradox, an epic story unfolding across unimaginable scales, inviting contemplation, speculation, and wonder. In reflecting on cosmic evolution, human consciousness becomes a temporal lens. Our perception is constrained by biological and cognitive scales, yet we can apprehend phenomena billions of years old. This juxtaposition highlights both the fragility and potency of awareness. We exist briefly, yet our understanding reaches across eons. Time, on the cosmic scale, is simultaneously a ruler, a story, and a mystery, demanding intellectual rigor while inspiring emotional awe. This duality forms the cinematic heartbeat of our narrative, bridging evidence-based science with speculative reflection. Finally, cosmic time lays the foundation for our next inquiry. If time is flexible at quantum and cosmic scales, what might this mean for consciousness, civilization, and the evolution of complexity? Could the universe itself possess structures or mechanisms where temporal flow is nonlinear, allowing for loops, echoes, or reversals across space and scale? The evidence we have examined, from inflation to black holes, from quantum uncertainty to galactic evolution, prepares us to explore these provocative questions. Science has mapped the broad strokes. Speculation invites us to imagine the possibilities. The stage is set for deeper exploration into the nature of time, consciousness, and reality itself. Imagine waking up one morning to find that every choice you made yesterday is undone today, that every consequence is replaced by its cause, and every memory is experienced in reverse. The world, once familiar, becomes uncanny. Meals eaten are uneaten. Conversations unheard are spoken backward, and every footstep retraces itself into uncertainty. This is the profound terrain of reverse time, where the flow of life, memory, and causality bends against our most intimate assumptions. In contemplating backward time, we are compelled to confront the deepest questions of consciousness, free will, and moral responsibility, challenging the very architecture of human understanding. Philosophers throughout history have wrestled with time, yet always under the assumption of forward progression. Aristotle conceived time as the measure of motion, intrinsically linked to change and succession. For him, moments follow one another, a linear continuum enabling understanding, planning, and reflection. If time were reversed, the logical scaffolding upon which knowledge rests would crumble, causality would invert, and memory would no longer guide action, but merely replay events already undone. Human, Experience would shift from a narrative driven by intention to a pattern dictated by outcome, forcing a radical reevaluation of agency. The very notion of cause and effect, so central to thought, would dissolve, leaving consciousness in a cinematic loop of reversed unfolding. Kant, centuries later, deepened the conceptual framing by positing time as a fundamental lens of human perception, a structuring principle imposed by the mind on raw experience. Time organizes events, orders memories, and shapes anticipation. In a backward-flowing reality, Kant's intuition would be inverted. Anticipation becomes retrospection. Planning becomes reflection on outcomes yet to proceed. The mind, attuned to linearity, would face cognitive dissonance of unparalleled magnitude. Imagine recalling the end of an action before initiating it, perceiving regret before desire, witnessing completion before conception. Memory, morality, and emotion would be untethered from the causative chains that give them meaning. And yet, paradoxically, consciousness might adapt, developing its own internal logic for reversed experience. Reverse time also magnifies questions of free will. In forward time, choices appear to originate from intentionality. We deliberate, decide, and act. Yet, if causality runs backward, decision and consequence are inverted. The outcome precedes deliberation, and intention becomes a reflection rather than a source. Philosophers and neuroscientists alike have debated the illusion of free will even in normal time. Under reverse temporality, these debates acquire urgent, almost cinematic weight. Could we genuinely act freely, or would our sense of volition be an emergent artifact, a backward projection of events already determined by their consequences? This tension between perception and reality, between autonomy and determinism, forms the heart of human experience under reverse time, where moral choice becomes a puzzle without clear anchors. Consider morality itself. Ethical judgments rely on understanding cause and effect. Actions produce outcomes, and consequences guide evaluation. In a backward temporal universe, harm precedes intention, virtue follows wrongdoing, and the ethical compass spins unpredictably. Imagine apologizing before committing a misdeed, or feeling guilt before a thought arises. Responsibility becomes a mirror, reflecting consequences onto origins in ways that defy intuition. Yet even here, there is cinematic drama. The inversion forces us to confront the essence of morality itself. Is it grounded in outcomes, intentions, or something deeper? Reverse time magnifies these questions, inviting reflection on the foundations of ethics, empathy, and human interconnectedness. Emotion, too, would be profoundly affected. Love, grief, and anticipation rely on temporal sequence. We fall in love, endure loss, and hope for the future. In reverse time, grief might precede loss. Joy arrives after despair, and longing resolves into nostalgia before desire even forms. The emotional landscape transforms into a cinematic tableau of anticipatory echoes, where each feeling traces backward through its cause, generating a dissonant yet fascinating experience. The heart's rhythm aligns not with linear passage but with temporal inversion, producing a form of consciousness simultaneously alien and deeply human. The mind adapts, narrating life in a reverse chronology that challenges but also enriches understanding of existence. Memory, the repository of personal history, faces its most profound challenge under reverse temporality. Normally, memory guides decision-making, informs learning, and shapes identity. If events unfold backward, memory becomes anticipation in disguise. We remember the future before experiencing the past. Each recollection is prelude, each recollection a paradox. The cinematic imagery is compelling. One stands at the precipice of understanding outcomes before witnessing actions, threading the needle of self-awareness through loops that twist causality. Identity itself becomes a temporal performance, a narrative unspooling in reverse while retaining coherence through conscious adaptation. Philosophical thought experiments illuminate the stakes. Imagine a courtroom of reverse time. Evidence arrives before the crime. Witnesses testify before the act, and judgment precedes accusation. Justice, predicated on linear causality, becomes an intricate puzzle of perception and anticipation. The moral framework, so dependable in forward time, becomes fluid and paradoxical. Similarly, interpersonal relationships would acquire a spectral quality. Reconciliation might precede offense. Forgiveness arrives before harm, and understanding evolves from outcomes into intentions. Reverse time forces humanity to confront the foundations of meaning itself, emphasizing that our concepts of causality, ethics, and emotion are inseparable from the arrow of time we experience. Speculative theories in modern philosophy extend these ideas even further. Some suggest consciousness itself might influence temporal flow, echoing interpretations in quantum mechanics, where observation collapses possibilities. If mind interacts with time at fundamental levels, then reverse temporality could yield new forms of cognition, where awareness navigates backward streams of cause and effect. The cinematic potential is extraordinary. Thought becomes a medium for temporal exploration, memory a compass pointing both forward and backward, and perception a bridge linking experience across the dimensions of time. Here, science and philosophy intersect, each reinforcing the plausibility of scenarios once deemed purely fantastical. Human culture, too, would undergo transformation. Narratives, stories, and histories are structured around temporal progression, beginnings, middles, ends. Reverse time would rewrite this logic. Literature, art, and music might emerge as sequences designed to be experienced backward. A symphony whose resolution precedes introduction, a story whose climax precedes exposition. The aesthetic and existential impact would be profound, emphasizing that human creativity is intimately tied to temporal direction. Inverting time reshapes not only cognition but culture itself, highlighting the interplay between perception, expression, and the universal flow of events. Existential reflection deepens under the weight of reverse time. Life, death, and the search for meaning acquire layers of paradoxical significance. If events are experienced backward, does purpose precede action, or does reflection shape destiny retroactively? The cinematic imagery is stark. A human existence unfolding in reverse, each life an intricate mosaic of causes and consequences inverted. Yet within this inversion lies potential beauty. Understanding emerges not only from what is done, but from what is undone. Consciousness reframes itself in light of outcomes, and the universe becomes a stage for temporal exploration as rich, emotionally as it is intellectually. The tension between forward and backward time also resonates with contemporary debates in physics and philosophy. Classical determinism, rooted in Newtonian mechanics, assumes predictable progression. Quantum mechanics, as explored earlier, challenges linearity at fundamental levels. Reverse temporality magnifies these tensions, extending them into human experience. The mind, the self, and the moral compass are tested against a backdrop where traditional frameworks falter, yet the imagination flourishes. Science provides the evidence of possibility. Philosophy illuminates the consequences. Together, they create a cinematic meditation on existence, inviting awe, wonder, and reflection. In imagining life, in reverse, one confronts the paradox of understanding. If causes follow effects, can we truly comprehend our own actions? Do memories and intentions retain meaning when inverted? The cinematic power of this question is profound. Consciousness becomes both observer and participant, navigating a world where every decision is a reflection, every emotion a prelude, and every life a narrative unfolding backward yet experienced fully. Existential reflection deepens as viewers confront the core mystery, whether comprehension requires linearity or whether understanding can emerge from the inversion itself. Finally, the philosophical journey of reverse time underscores the fragility and adaptability of human cognition. Minds shaped by forward progression may initially falter, yet consciousness possesses remarkable flexibility. Awareness, reflection, and emotion could recalibrate to a world in which causality is inverted, forging new frameworks for meaning. The cinematic imagery is both intimate and cosmic, a single human mind navigating reversed experience, connected to the universe's temporal fabric, negotiating agency, morality, and identity in unprecedented ways. It is a meditation on possibility, an exploration of the profound interplay between time, self, and understanding. Reverse time, then, is not merely a scientific curiosity, it is a philosophical frontier. It challenges assumptions about memory, choice, morality, and identity. It forces reflection on what it means to act, to know, and to exist. By imagining backward time, we explore not only the limits of physics, but the depths of human experience, confronting a world where the familiar arrow of causality is replaced by a tapestry of reversed flows, paradoxical loops, and cinematic beauty. In this space, consciousness and philosophy merge, creating a narrative that is at once intellectually rigorous, emotionally resonant, and profoundly awe-inspiring. As we prepare to move from the human and philosophical dimensions into the realm of speculative possibilities on a cosmic scale, the groundwork is set. We have examined how reverse time would reshape experience, challenge morality, and redefine consciousness. The journey now extends outward, toward broader questions of the universe itself, multiversal scenarios, and the interplay of time, space, and reality on a scale that dwarfs individual existence. The philosophical lens, sharpened by human contemplation, will guide us as we explore these expansive frontiers, bridging cognition, cosmology, and existential wonder. Long before the telescope and the particle accelerator, humans looked to the sky and to the cycles of the earth, seeking patterns in the passage of days, seasons, and celestial movements. Time was not merely measured. It was imagined, felt, and woven into stories that shaped culture, belief, and consciousness. Ancient civilizations perceived time as something both tangible and mysterious, structured yet cyclical, linear yet echoing with repetition. From the sundials of Mesopotamia to the astronomical alignments of Stonehenge, humanity has always sought to understand the rhythms of existence, intuitively probing questions that modern physics now formalizes. Is time fixed, fluid, or even reversible? In Mesopotamia, the earliest known civilization of written records, priests and astronomers meticulously observed celestial cycles. They constructed calendars not simply to organize agriculture, but to align human life with cosmic rhythm. Time was cyclical. Days became months, months became years, and years repeated in a sacred harmony. Festivals, rituals, and myths reinforced this vision of a universe governed by recurring cycles. Kingship, divine favor, and human destiny were all thought to resonate with cosmic order. The Mesopotamian imagination embraced both structure and mystery, acknowledging that time flowed according to patterns far grander than individual perception. Here, the seeds of contemplating reversal and recurrence were already planted. Across the Nile, the Egyptians cultivated an intricate understanding of temporal rhythm through both observation and symbolism. Temples, pyramids, and the alignment of monumental structures with stars like Sirius reflect a culture deeply attuned to celestial time. Myths of Osiris, whose death and resurrection echo cycles of the Nile and agricultural renewal, suggest that time was not purely linear but recursive, capable of turning back upon itself in spiritual and cosmic terms. The Egyptian calendar and their rites of passage conveyed a sense that beginnings and endings are intertwined. a notion that resonates with modern ideas of temporal loops and backward causality. Cinematically, one can imagine the sun rising over the Giza Plateau, casting shadows that mark hours, centuries, and mythic cycles, blending observation, ritual, and cosmic contemplation. The Mayans of Mesoamerica offer another vivid illustration. Their long count calendar, designed to track cycles spanning thousands of years, frames time as both cyclical and prophetic. Periods known as Bactans end and begin, creating a narrative of cosmic renewal. Myths of cosmic reversal, such as the return of the gods or the resetting of ages, reflect a worldview in which past, present, and future are interconnected. Here, time is not a linear arrow but a spiral, each loop echoing the last, suggesting patterns that repeat across generations. The Mayan conception parallels contemporary discussions of multiverse cycles and entropy reversal, hinting that ancient humans, through myth and observation, intuited the fluidity of temporal experience long before physics formalized the concept. Hindu cosmology further deepens this cinematic vision. Time is measured in yugas, vast epochs spanning thousands of years, each with distinct characteristics, cycles of creation, preservation, and dissolution. The universe itself undergoes rhythmic birth, decay, and rebirth. In these myths, cosmic reversal is implicit. Ages regress, the world renews, and events repeat across scales so vast that individual human life seems both fleeting and part of an eternal continuum. Philosophically, this perspective resonates with modern speculations on nonlinear time, loops, and multiversal recurrence. By juxtaposing these narratives with contemporary physics, a cinematic picture emerges. Humanity has long sought to understand the universe's hidden temporal architecture, blending observation, intuition, and imagination. Even in the Western classical tradition, time was a subject of philosophical reflection that often bordered on the mythic. The Stoics conceived the universe as an eternal recurrence, a fire that consumes and renews itself, suggesting a cosmos where events might repeat across epochs. Ancient Greek myths, like the Ouroboros, the serpent consuming its own tail, symbolize cycles of self-containment, reversal, and regeneration. These symbols convey an intuitive understanding of temporality as complex, layered, and, at times, paradoxical. By tracing these threads from myth to philosophy, we see that humans have always wrestled with questions that modern science now confronts with mathematics and observation. What is the nature of time? Could it loop, reverse, or fold upon itself? Ancient observatories and structures provide concrete evidence of this fascination. Stonehenge in England, with its precise alignment to solstices, encodes both practical knowledge and symbolic meaning. Its massive stones cast shadows that mark solar and lunar cycles, connecting human activity to cosmic rhythm. Similarly, the Mayan observatories at Uxmal and Chichen Itza, or the astronomical ceilings of the Temple of Hathor in Dendra, visualize time through architecture, mapping celestial phenomena onto human experience. These structures, cinematic in scale and design, serve as testimonies to humanity's enduring desire to synchronize life with cosmic order. Time was observed, encoded, and imagined as a malleable, almost tangible force. Cultural myths frequently explore reversal and cyclical renewal. The Norse myth of Ragnarok, describing the destruction and rebirth of the world, portrays time as reversible on a cosmic scale. Catastrophe leads to renewal, endings beget beginnings. Similarly, in East Asian traditions, cycles of dynastic rise and fall mirror natural rhythms, emphasizing repetition and return. These stories, though symbolic, share an underlying recognition. Linear time is insufficient to capture the full complexity of existence. Human imagination, like modern physics, seeks a deeper, more nuanced account of temporal reality, one that accommodates paradox, recurrence, and reversal. It is striking to observe how ancient and modern frameworks, though separated by millennia, converge in certain ways. Just as quantum mechanics and cosmology hint at non-linear, context-dependent, or reversible temporal phenomena, myth and ritual illustrate an intuitive grasp of these possibilities. Civilizations encoded these insights in story, structure, and symbol, creating a cultural memory of time that resonates with contemporary science. The cinematic effect is profound. Ancient observatories, celestial alignments, and mythic narratives unfold as visual metaphors for temporal complexity, bridging imagination with observation, intuition with calculation. Sundials and water clocks further embody this fusion of practicality and speculation. Timekeeping instruments mark linear progression in the observable world, yet their design often acknowledges celestial cycles, seasonal patterns, and anomalies that escape simple linear interpretation. Shadow, flow, and motion are both measured and symbolic, reminding observers that time is both a tool and a mystery. Imagine a sunbeam tracing an arc across a stone dial, connecting human measurement to cosmic rhythm, linking lived experience to celestial motion. In this cinematic frame, time is simultaneously concrete and ethereal, tangible yet elusive, a motif echoed in both mythic imagination and modern physics. Artistic representations, from petroglyphs to temple reliefs, reinforce this perspective. Depictions of cycles, reversed motion, and cosmic order illustrate that ancient cultures visualized time in multidimensional ways. Cosmic serpents, spirals, and repetitive motifs appear across continents, suggesting a shared, perhaps intuitive, understanding of temporal flow that transcends geography and culture. When juxtaposed with scientific theories of time loops, retrocausality, and nonlinear cosmology, these ancient expressions assume new significance. They are more than cultural artifacts. They are early attempts to model reality, blending observation, ritual, and speculation into cinematic narratives of existence. Contrast is essential here. Myth versus measurement, imagination versus empiricism, cyclical perception versus linear observation. Yet in both domains, humanity confronts the same fundamental mystery. Ancient observers, armed with naked eye, simple instruments, and profound intuition, grappled with questions now formalized in physics and cosmology. Their symbolic and mythic frameworks anticipated the possibility of temporal reversal, cycles of causality, and nonlinear progression. Modern science, precise and quantitative, provides evidence and predictive power, but it continues the human quest the mythology initiated to understand the deep, often paradoxical nature of time. By exploring ancient perspectives, we also glimpse the emotional and existential dimension of temporality. Humans have long used myths, rituals, and architecture to align themselves with time, seeking meaning, continuity, and coherence in a vast, often incomprehensible universe. Cosmic reversals, recurring epochs, and symbolic representations of time are not mere abstractions. They are attempts to situate consciousness within the larger temporal framework. The cinematic vision is compelling. From the shadow of a gnomon at sunrise to the spiral of a celestial motif on temple walls, human awareness engages with time both practically and philosophically, mapping existence onto the rhythms of the cosmos. Ancient perspectives also illuminate the human capacity for speculation. Just as quantum mechanics challenges classical causality, myths challenge linear thinking. Tales of gods reversing fate, of worlds destroyed and reborn, of celestial bodies cycling through recurring patterns, are narratives that embrace temporal flexibility. These stories are not scientifically precise, yet they resonate with the same principles explored in modern physics: recurrence, reversal, and nonlinearity. In viewing these myths through a cinematic lens, one sees the enduring human fascination with the possibility that time is more malleable than daily experience suggests. Ultimately, bridging ancient and modern views creates a dialogue between culture and science. The ancients provide intuition, imagination, and symbolic richness. Contemporary physics provides evidence, predictive frameworks, and conceptual rigor. Together, they form a cinematic continuum in which time is both measurable and mysterious, linear and cyclical, perceptible and elusive. Observatories, temples, myths, and rituals become visual metaphors for the human quest to understand temporality. The story of time is not merely scientific or philosophical, it is cultural, mythic, and cinematic, unfolding across civilizations, epochs, and stars alike. Dawn as we conclude this exploration. One central idea emerges. The human imagination has always anticipated the complexities of temporal reality that modern physics now grapples with. Cycles, reversals, and cosmic rhythms appear across cultures, encoded in observation, myth, and ritual. Ancient civilizations perceived that time might not be strictly linear, that causality could be fluid, and that consciousness interacts with temporal flow in subtle, profound ways. The cinematic impact of these insights is staggering. Humans, standing beneath the stars, interpreting shadows, aligning structures, and weaving stories, were already reaching toward the mysteries of temporal reversibility, multiverse cycles, and cosmic rhythm that today's science seeks to formalize. This convergence of mythic, imagination, and empirical inquiry sets the stage for our next exploration, the intersection of human consciousness and the perception of time, where neurological, cognitive, and philosophical perspectives illuminate how our minds navigate temporal flow, whether forward, backward, or in paradoxical loops. Ancient insight meets modern investigation, creating a narrative that is both intellectually rigorous and emotionally immersive, bridging civilizations, cosmos, and consciousness itself. Imagine opening your eyes to a world where cause follows effect, where the arrow of time is not a straight line but a path that twists, turns, and occasionally doubles back on itself. In this speculative horizon, the familiar routines of life are inverted. Conversations begin with conclusions and end in greetings. Meals are uneaten before they are cooked, and relationships dissolve before they are formed. Daily existence becomes a cinematic tapestry of reversed motion, an ever-unfolding puzzle that challenges our understanding of continuity, choice, and consequence. To inhabit such a world mentally is to confront the profound implications of reverse temporality, to see life as a sequence of unraveling events, and to question the very structure of reality itself. Consider human aging in a backward-flowing world. Children emerge as adults and gradually shrink into infancy. Memories of youthful experiences dissolve before they are formed, and knowledge acquired over decades disappears as quickly as it was gained. Birth is experienced as a convergence of endpoints rather than the start of potential. Cinematically, the visual is arresting. A bustling cityscape where people grow younger with each passing day, wrinkles smoothing, hair returning to its original hue, and the accumulation of life experience rewinding into the oblivion of early childhood. Emotionally, the scene is both tragic and mesmerizing, a meditation on impermanence and the elasticity of human experience. Daily interactions transform into paradoxical narratives. Imagine saying goodbye before greeting, apologizing before misdeeds, or celebrating achievements before attempting the tasks that lead to them. Communication becomes a complex choreography where intent trails outcome and comprehension is retroactive. Conversations, normally anchored in sequence, now unfold like cinematic reverse montages, each line of dialogue predicated on events yet to precede it. The human mind, attuned to linearity, faces cognitive contortions, understanding meaning without traditional temporal anchors, reinterpreting causality not as a guide, but as a reflection, and navigating relationships in a temporally inverted world. Speculative physics suggests that reversing entropy, the natural tendency of systems to move from order to disorder, could magnify these experiences. Ice melts in a sunbeam, flames retreat into logs, and stars reassemble from scattered cosmic dust. The cinematic imagery is staggering. A bustling metropolis dissolves in reverse. Smoke retreats into chimneys. Shattered glass leaps upward to form intact windows. And vehicles uncrash themselves as if obeying a hidden retroactive script. In such a universe, the laws of thermodynamics as we know them bend, inviting contemplation of a cosmos where order and chaos dance in reverse, and where the familiar constraints of physics are both inverted and surreal. Temporal reversal also provokes intriguing thought experiments about communication with the past. Could messages sent backward in time alter events before they occur? If causality is fluid, might warnings or guidance from the future reshape history retroactively? These scenarios blend scientific plausibility with imaginative speculation, highlighting both the limitations of our understanding and the limitless scope of possibility. Cinematically, the notion evokes scenes of handwritten letters appearing spontaneously on desks, conversations echoing backward across centuries, and civilizations subtly nudged by knowledge that is yet to be acquired in linear experience. The tension between evidence and imagination fuels wonder, drawing viewers into the heart of temporal mystery. Alternate histories emerge naturally from such speculation. If every event can unfold backward, countless possibilities proliferate. Wars dissolve into peace, monuments vanish before they are constructed, and societies regress into earlier forms of organization. Cultural evolution rewinds, languages unlearn themselves, and civilizations dismantle the edifices of their achievements as if rehearsing for an unrecorded prologue. The cinematic potential is immense. Imagine a grand cityscape like Rome or Cairo in reverse. Buildings rising from rubble into splendor, only to vanish as their foundations ascend into the void. History, usually a linear narrative, becomes a kaleidoscope of cause and effect, where the past is both familiar and alien, a realm to be explored in imagination and speculation alike thought everyday science. 2. Would experience dramatic inversion. Clocks tick backward, rivers flow uphill, and plant growth retracts to seed. Human labor, normally a process of construction and creation, is transformed. Artists' paintings vanish stroke by stroke. Engineers' bridges collapse back into raw materials, and scientific experiments regress to their initial conditions. Cinematically, laboratories become stages of temporal reverse magic, where observation and experimentation are acts of unmaking as much as understanding. This inversion encouraged contemplation of the fragility of knowledge and the impermanence of achievement when time itself flows contrary to expectation. The ethical dimension of backward time becomes strikingly complex. Imagine crime and punishment unfolding in reverse. Arrests precede offenses. Justice anticipates wrongdoing, and accountability becomes an intricate dance of anticipation rather than consequence. Moral causality, which normally guides human behavior, becomes a cinematic puzzle of retroactive responsibility. Could one be held accountable for a misdeed that is yet to be conceived? Would intention retain significance if the outcome predates the act? These questions challenge conventional frameworks of law, ethics, and responsibility, transforming philosophical inquiry into a lived, experiential scenario that is as emotionally compelling as it is intellectually provocative. Speculative horizons extend to collective human experience. Societies might unbuild technology, rediscover forgotten knowledge in reverse, and unlearn innovations that once defined civilizations. Education, memory, and culture regress in temporal sequences that are both fascinating and unsettling. Cinematically, one could envision a university campus where students leave lectures before the lessons are taught, libraries where books dissolve into blank pages, and entire networks of human knowledge unfolding backward like a river retracing its course to the source. This visual spectacle illuminates both the power and fragility of human achievement when placed within a temporally flexible universe. Even natural landscapes are transformed under reverse time. Mountains shrink back into hills, rivers flow toward their sources, and forests disassemble into saplings and seeds. The cinematic imagery is breathtaking. Entire ecosystems unfold in reverse, revealing the delicate choreography of life in motion. Animals retrace migratory paths, predators uncapture prey, and evolutionary changes regress into ancestral forms. This grand visual narrative creates awe, emphasizing the interconnectedness of life, the reversibility of natural processes, and the intricate temporal architecture that underlies the living world. Speculation becomes a lens for perceiving the universe in ways that challenge human intuition, expanding imagination while anchoring it in observable principles. The interplay of technology and reverse temporality opens further possibilities. Imagine computers computing backward, machines disassembling themselves as if rewriting history, and AI tracing outputs to original inputs before problems were posed. Cinematically, data flows regress through networks. Code dissolves into logic, and the digital realm mirrors the inverted physical world. The tension between functionality and inversion underscores the fragility of human-made systems. In the face of temporal reversal, highlighting both the cinematic drama and intellectual challenge of inhabiting such a universe, speculative scenarios also invite exploration of consciousness. If humans perceive time backward, memory, thought, and awareness adjust accordingly. Decisions are informed by outcomes yet to be experienced, and reflection precedes action. Emotion, cognition, and creativity navigate inverted sequences, revealing the adaptive capacity of consciousness in extreme temporal environments. The cinematic visualization is intimate yet cosmic, individual minds tracing backward arcs of experience while societies, history, and natural systems do the same, creating a tableau of interlinked reversal that is simultaneously alien and familiar. Space-time itself becomes a playground for speculative imagination. Celestial events, supernova, planetary formation, and galactic collisions unfold in reverse. Stars coalesce from clouds of dust, black holes eject matter, and cosmic expansion contracts toward an origin. These images are cinematic in scale, merging scientific plausibility with imaginative grandeur. Observing the universe in backward motion fosters awe, reinforcing the notion that time is a flexible dimension, and that human perception is but one lens through which its complexity can be glimpsed. Entropy reversal introduces paradoxical energy flows. Heat moves from cold to hot, chemical reactions regress, and physical decay becomes a form of temporal sculpture. The cinematic impact is profound. Imagine a cityscape where rust retreats from steel, pollution retreats from rivers, and ecological systems self-repair in reverse. Life itself gains a surreal, almost magical dimension, where cause and effect are disentangled, and the familiar rules of progression are supplanted by a universe of intricate, interwoven reversals. The result is both intellectually provocative and emotionally stirring, a tableau that challenges the imagination while maintaining conceptual plausibility. Speculative horizons also extend to time travel in the human imagination. Could individuals inhabit the past in real time, experience history firsthand, or influence events retroactively? These questions hover between scientific theory and narrative speculation, evoking cinematic scenes of explorers witnessing the construction of civilizations, conversations unfolding across centuries, or choices influencing outcomes already realized. By blending physics, philosophy, and imagination, these scenarios maintain credibility while fostering a deep sense of wonder, compelling viewers to inhabit worlds that are at once alien and intellectually exhilarating. Alternate Personal histories emerge when daily lives are reversed. Careers, relationships, achievements, and mistakes unwind before one's eyes. Cinematically, one might watch a person's life trace backward from retirement to childhood. Friendships dissolve before formation, and love unfolds in reverse, leaving joy, regret, and memory in temporal suspension. This inversion reframes existential reflection, illustrating that identity, narrative, and consciousness are deeply intertwined with the direction of time, and that reversing temporal flow offers a lens to explore the human condition in novel, profoundly cinematic ways. Civilizations themselves become subjects of temporal speculation. Nations rise and fall in reverse. Wars retreat into diplomacy, cities collapse into villages, and empires deconstruct into local communities. History unfolds as a cinematic reverse montage, emphasizing patterns, consequences, and cultural flux in unprecedented ways. This perspective reinforces that time is not merely a measurement, but a medium through which meaning, order, and chaos interact. Speculation becomes a tool for exploring contingency, resilience, and the malleability of reality on scales that stretch from individual experience to cosmic evolution. Even mundane acts, writing a letter, planting a tree, cooking a meal, gain dramatic, cinematic resonance. Each action unravels, revealing interdependencies and causal chains previously unnoticed. Observers, inhabiting this speculative world mentally, perceive the fragility of sequence, the artistry in reversal, and the profound beauty of temporal interplay. Daily life transforms into a living narrative of discovery and paradox, where cognition, emotion, and imagination converge in a rich tapestry of cinematic wonder. In inhabiting these speculative scenarios, viewers are encouraged to stretch both imagination and intellect. Reverse time is not merely a thought experiment. It is a lens through which to explore causality, consciousness, society, and the universe itself. It blurs boundaries between science and myth, reality and imagination, certainty and possibility. By visualizing humans, civilizations, and natural systems unfolding backward, audiences gain not only aesthetic pleasure, but also cognitive insight into the profound contingency of existence and the intricate architecture of temporal flow. As the mind navigates these horizons, it becomes clear that the interplay of evidence and speculation is essential. Scientific plausibility grounds the imagination, ensuring that speculation resonates with known principles of physics, thermodynamics, and cosmology. At the same time, imaginative exploration expands the horizon, revealing possibilities that logic alone cannot fully contain. Cinematic storytelling, in this context, becomes a bridge. It renders abstract concepts tangible, emotionally compelling, and intellectually stimulating, inviting viewers to inhabit a world simultaneously alien and intimately human. By exploring backward-flowing daily life, communication with the past, entropy reversal, and alternate histories, we begin to understand time not as a rigid arrow, but as a pliable, multi-dimensional medium. Each speculative scenario highlights contrasts between predictability and uncertainty, causality and paradox, perception and reality. The cinematic potential of such reversals is immense, allowing viewers to mentally inhabit worlds where every choice, event, and consequence unfolds backward, yet coheres into a narrative that is both gripping and profoundly thought-provoking. Ultimately, speculative horizons of reverse time invite reflection on the human imagination itself. They reveal that our minds are equipped to model worlds far beyond ordinary experience, to entertain paradox, and to explore scenarios that challenge intuition while remaining tethered to plausibility. By mentally inhabiting these cinematic sequences, audiences engage in a form of experiential cognition, understanding temporal reversal not only conceptually, but emotionally and existentially. The universe, in these speculative vistas, is both familiar and alien, a stage for drama, wonder, and profound contemplation. As we prepare to transition from speculative imagination back to the philosophical and existential implications of time itself, the stage is set. We have traversed daily life in reverse, explored communication with the past, witnessed entropy unravel, and imagined civilizations in temporal inversion. The next section will synthesize these insights, linking cosmic, quantum, and human perspectives to reflect on the ultimate meaning of time, memory, and existence, bringing viewers to a cinematic and intellectual climax that bridges awe, wonder, and contemplation. Time, as we experience it, is as intimate as the rhythm of our heartbeat, yet as vast as the cosmos. For centuries, humans have assumed that time is an external, objective dimension, flowing independently of consciousness, like a river that carries us along. But what if this assumption is incomplete? What if our perception of time, its past, present, and future, is not merely a reflection of external reality, but a construct of the mind itself? Neuroscience, psychology, and philosophy converge to suggest that consciousness does not merely passively observe time. It actively shapes it. The cinematic exploration of this idea begins with the intricate dance of neurons, each firing in patterns that encode memories, anticipate futures, and craft the subjective narrative we call experience. Consider the neuroscience of temporal perception. Neurons in the prefrontal cortex, hippocampus, and cerebellum work together to construct a sense of temporal continuity. Memories are encoded sequentially. Predictions of the future are generated from past patterns, and attention modulates the perceived speed of time. When we are engrossed in a task, minutes may stretch into hours. In moments of crisis, seconds can feel like eternity. These phenomena are not illusions. They reveal the mind's active role in constructing temporal reality. Cinematically, one can visualize these processes as a vast, luminous network of neurons firing in sync, producing an internal narrative that shapes our experience of duration, sequence, and causality. Altered states of consciousness deepen this insight. Psychedelic experiences, meditation, and near-death phenomena often disrupt the usual perception of time, collapsing past, present, and future into a simultaneous awareness or stretching single moments into expansive, cosmic durations. In these states, the mind detaches from conventional chronological order, revealing that what we call time may be a flexible framework, dependent upon the architecture and dynamics of consciousness. Imagine a dreamlike sequence where memories and expectations flow fluidly, past events blend with imagined futures, and the linearity of experience dissolves into a vast, immersive temporal tapestry. Such visualization invites viewers to question, if time is constructed by consciousness, what happens when its architecture is altered or reversed? Philosophers have long pondered these questions. Immanuel Kant proposed that time and space are forms imposed by the mind to structure experience. They are not properties of the world in itself, but lenses through which phenomena appear. Subjective experience shapes the narrative of reality. If Kant is correct, then reversing our perception of time could conceivably alter the very reality we inhabit. Cinematically, this idea manifests as a shifting landscape. Scenes unfold simultaneously forward and backward. Cause and effect blur, and human experience is portrayed as a chorus, multi-layered construct where reality itself is contingent upon the mind's temporal framework. Contemporary cognitive science provides empirical support for this perspective. Experiments demonstrate that our brains actively interpolate, extrapolate, and sometimes distort events to maintain temporal coherence. Memories are reconstructed, not replayed. Perceptions are predictive, not purely reflective. Consciousness edits the flow of time, smoothing irregularities, anticipating outcomes, and generating a sense of continuity. Viewed cinematically, This neural activity resembles an intricate loom, weaving threads of experience into coherent temporal narratives. The implication is profound. Reality as we perceive it is inseparable from consciousness, and any alteration in temporal perception reverberates across our lived experience, reshaping cause, effect, and meaning. Consider the phenomenology of memory. When recalling past events, the mind does not simply replay objective recordings. It reconstructs experiences influenced by context, emotion, and expectation. Memories are both backward-looking and forward-referencing, incorporating past input while anticipating future coherence. If consciousness were to experience time in reverse, memories might dissolve before events occur, shaping anticipation and understanding in unprecedented ways. Cinematically, one might envision sequences where recollection and experience interweave, past and present colliding, and human identity itself becomes a fluid, temporally dynamic phenomenon. The emotional resonance of such a world is immense. Joy, regret, love, and fear are all refracted through a lens where cause follows effect, and perception guides reality. Dreams offer another portal into temporal fluidity. In dreaming states, chronological order is often suspended. Events unfold in symbolic sequences, unrelated to linear causality, yet we perceive them as coherent within the dream. This suggests that the mind is capable of simulating experiences outside conventional temporal flow. Imagine a cinematic montage, dreamscapes where events rewind and loop, characters interact across time, and landscapes shift unpredictably. These sequences mirror speculative scenarios of reversed or nonlinear time, reinforcing the idea that perception, not external, clocks defines the texture of temporal experience. Neurological anomalies further illuminate the interplay of consciousness and time. Patients with certain brain injuries or disorders, such as lesions to the parietal cortex or disruptions of the hippocampus, report altered time perception. Hours may feel like minutes, sequences become jumbled, and cause and effect relationships invert. Such cases demonstrate that time, as we know it, is inseparable from neural function. Cinematically, this can be visualized as a labyrinthine neural network where signals misfire, loops form, and temporal continuity becomes fluid, illustrating the brain's central role in shaping the very flow of experience. Philosophical thought experiments push these insights further. Imagine a universe in which consciousness dictates the direction of time. Minds perceive events backward. Neurons fire in reversed sequences, and subjective experience governs physical processes. The distinction between past and future blurs, and causality becomes a function of perception rather than external constraint. Cinematically, one can picture individuals inhabiting lives where actions precede intentions, outcomes precede choices, and reality itself feels malleable. Such speculation, while extreme, underscores the entanglement of consciousness and temporality, highlighting the profound consequences of reversing perceptual flow. The link between time and selfhood is equally compelling. Our sense of identity relies on continuity, a narrative constructed from memories, experiences, and anticipations. If temporal perception were reversed, this narrative scaffolding might invert. The self would unravel in reverse, identities deconstructing as memories dissolve before formation. Cinematically, the human figure becomes a vessel for temporal exploration. Faces, gestures, and emotions rewind through life, leaving viewers with a haunting meditation on impermanence, memory, and the deeply personal dimension of temporal perception. Attention and expectation also modulate subjective time. Cognitive psychology demonstrates that focus can accelerate or decelerate perception. Waiting for an event elongates moments, while immersion in activity compresses them. If consciousness could inhabit reverse time, these effects would be amplified. Anticipation of past events, attention to outcomes before actions, and focus on dissolving memories would redefine experience. Cinematic narration can visualize this as a kaleidoscopic interplay of moments, where attention shapes the unfolding sequence, highlighting that subjective experience is not a passive reflection, but an active, creative force in temporal construction. Even simple sensory experiences acquire profound implications. The perception of sound, motion, and visual sequences is temporally structured. Neurons encode order, rhythms, and duration. In reverse time, these patterns invert. Music unplays, speech reconstructs from echoes, and motion regresses. Cinematically, one could imagine symphonies dissolving into silence, spoken words retracting into thought, and actions tracing backward arcs. These visual and auditory metaphors underscore the deep entanglement of perception, cognition, and temporal reality. Time, in this sense, is both physical and experiential, a dynamic interplay between mind and universe. Neuroscientists also explore the plasticity of temporal perception. Training, meditation, or cognitive exercises can expand the perceived duration of events, enabling humans to inhabit time more flexibly. Such plasticity suggests that consciousness can modulate the very experience of sequence, duration, and causality. Imagine cinematic sequences of individuals inhabiting elongated or compressed temporal frames, perceiving multiple outcomes simultaneously and navigating parallel experiences. These visualizations bridge scientific insight with speculative imagination, illustrating that time is not fixed but intimately intertwined with consciousness. Cultural and philosophical reflections reinforce these insights. Eastern philosophies, such as Buddhism and Taoism, often describe time as illusory, emphasizing the present moment as the locus of consciousness. Western phenomenology similarly highlights the constructive nature of temporal experience. By contrasting subjective perception with physical time, we see that reality itself is filtered through the mind's interpretive framework. Cinematic narration can depict consciousness as both lens and creator. The universe appears as a dynamic, responsive tableau, shaped by observation, memory, and attention. If perception dictates time, reversing it would entail profound consequences for reality itself. Events could unfold according to the mind's reinterpretation. Outcomes might precede intentions, and the boundary between internal and external experience could dissolve. The cinematic potential here is staggering. Individuals interacting with the environment in nonlinear sequences, landscapes and cities reshaping according to cognitive focus, and subjective reality tracing loops, folds, and reversals that challenge conventional understanding. Consciousness becomes not just observer, but participant in the temporal architecture of existence. Dreams, altered states, and neurological phenomena suggest that such experiences are not entirely fantastical. Our brains are capable of constructing alternative temporal realities, simulating sequences independent of linear causality, and integrating complex temporal patterns into coherent experience. Cinematic visualization of these processes reveals a universe both intimate and vast. Neural activity mirrors cosmic flow. Subjective narrative echoes cosmic rhythms, and the mind becomes a bridge between human perception and universal temporality. The distinction between inner and outer time begins to blur, creating a cinematic perspective where consciousness and cosmos intertwine. Temporal perception also governs emotion. Anticipation, regret, hope, and fear are all anchored in the direction of time. Reversing this flow would invert emotional experience. Grief might precede loss. Joy would follow outcomes, and love could dissolve before formation. Cinematically, sequences of human interaction unfold backward, revealing subtle causal links between emotion and temporal orientation. This emphasizes that time is not merely a measure, but a medium through which experience, meaning, and affect are constructed. The reversal of temporal flow amplifies these dynamics. creating both cognitive challenge and emotional resonance. In exploring consciousness and temporal perception, we confront the paradox of subjectivity. Our minds construct a coherent narrative from fragmentary inputs, shaping time even as it shapes us. Reversing perception would not merely reorder experience, but potentially restructure reality, blurring boundaries between memory, action, and outcome. Cinematic narration can illustrate this with dreamlike sequences, neural imagery, and immersive visualizations of experience unfolding backward. The audience is invited to inhabit these perspectives, to sense the fragility and creativity of consciousness, and to contemplate the profound link between mind and time. Finally, bridging neuroscience, philosophy, and speculative thought, one recognizes that the human mind is both observer and architect of temporality. By manipulating perception, imagination, and attention, consciousness shapes the flow, density, and coherence of experience. Reversing this flow invites reflection on the nature of reality itself. Is time an external river, or a construct emerging from our neural and cognitive architecture? Cinematically, this evokes a universe where brains, neurons, dreams, and landscapes interlace, creating an intimate yet cosmic tableau of temporal perception and consciousness. As we prepare to conclude this journey, the central question emerges once more. If our perception dictates time, could reversing it alter reality itself? The answer remains speculative, inviting awe, curiosity, and reflection. Through cinematic imagery, scientific insight, and philosophical exploration, we glimpse the profound entanglement of mind, time, and existence. From neurons firing to civilizations unmaking themselves, from dreams to cosmic rhythms, the temporal mind constructs, perceives, and navigates a universe that is at once measurable and mysterious, intimate and infinite. We began this journey with a single provocative question. What if time is flowing backward right now? From the swirling galaxies above to the flickering neurons within our minds, we have traced the contours of possibility, explored the frontiers of science, and ventured deep into the fertile landscape of imagination. Now, as we draw toward conclusion, it is time to weave these threads into a tapestry that embraces both the known and the unknown, the measurable and the ineffable, the certainty of observation and the mystery of speculation. Time, as science defines it, is a rigorous dimension, marked by equations, measurable intervals, and predictable sequences. Newton imagined a universe where time flowed uniformly, an invisible river guiding every motion. Einstein shattered this certainty, revealing that time bends, stretches, and entwines with space itself, its flow dependent upon speed and gravity. Quantum mechanics complicates the picture further. At microscopic scales, causality becomes fuzzy. Events can unfold in unexpected sequences, and particles seem to defy the linear order we take for granted. These insights, precise and empirical, anchor our understanding. Yet, even within this framework of rigor, the universe hints at reversibility, loops, and paradoxes that challenge our intuition, reminding us that certainty is always provisional and incomplete, speculative. Imagination stretches these insights into cinematic horizons. We envisioned a world where humans age backward, cities unmake themselves, and conversations unravel in reverse. We explored entropy reversing, cosmic events unfolding backward, and consciousness navigating time in a non-linear rhythm. These scenarios are not literal predictions, but mental experiments, tools to illuminate the pliability of reality and to expand our capacity for wonder. By inhabiting worlds that defy conventional sequence, we glimpse the flexibility of existence, the profound interplay between mind and universe, and the aesthetic beauty of temporality as an experiential medium. Philosophy invites us to reflect on what all of this means. Time is not merely an external measure, but a canvas upon which human consciousness paints narratives of memory, anticipation, and meaning. Aristotle considered time as intimately connected to motion and change. Kant proposed it as a structuring principle of perception. Our exploration has demonstrated that reversing time is not only a speculative exercise, but a lens through which to understand consciousness, identity, and causality. The question of backward time becomes, in essence, a question about the mind itself, how perception constructs reality, how narrative organizes experience, and how imagination expands the boundaries of possibility. Contrast, throughout this journey, has been our guiding frame. Science versus speculation, evidence versus wonder, reality versus imagination. Each duality illuminates the other. Where physics provides measurable predictions, imagination offers freedom to explore what is unmeasurable. Where certainty grounds understanding, mystery fuels curiosity. Where the tangible universe stretches billions of years across the cosmos, human consciousness condenses, expands, and reconstructs time within moments. These contrasts are not oppositions, but complementary lenses, each enriching our perception, each sharpening our sense of awe. Cosmic scales deepen the reflection. We considered the Big Bang, cosmic inflation, black holes, and galaxies spiraling across unimaginable distances. Here, time flows over billions of years, imperceptible to human experience, yet fundamental to cosmic evolution. Stars are born, live, and die, shaping the chemical landscape that allows planets and life to exist. If time were reversed on this scale, supernova would retreat into clouds, galaxies would collapse into primordial gas, and the universe itself would seem to replay its history. Cinematically, these visions are awe-inspiring. A dance of matter and energy, a symphony of creation and dissolution, revealing the universe as both timeless and temporally dynamic, mysterious and structured. On the human scale, backward time provokes existential reflection. Memory, choice, free will, and morality are entwined with the arrow of time. If events were reversed, would intentions still exist? Could ethics retain meaning if consequences precede actions? By considering these questions, we confront fundamental aspects of human experience, how identity is constructed through sequence, how relationships and decisions unfold, and how our awareness of mortality shapes purpose. Reversing time is not merely a thought experiment in physics. It is a meditation on what it means to live, to act, and to reflect upon existence. Consciousness, the intimate lens through which we perceive time, further complicates and enriches the narrative. Neurons encode, predict, and reconstruct experiences. Attention modulates the passage of moments, and dreams in altered states collapse temporal sequences into nonlinear awareness. Time is simultaneously external and internal, objective and subjective. Reversing perception would not simply reorder events, it would transform experience, emotion, and understanding itself. Cinematically, we can envision the brain as a luminous network, firing in patterns that weave the fabric of lived time, revealing the delicate interplay between mind and universe, perception and reality. Ancient perspectives remind us that grappling with time is as old as human civilization. Cyclical calendars, myths of cosmic reversal, and esoteric traditions suggest that the notion of nonlinear time is not new. Across cultures, humans have imagined eras looping back upon themselves, seasons and celestial cycles repeating, and life itself flowing in cyclical rhythms. These mythic analogies resonate with modern physics in unexpected ways. The universe may be more flexible than linear logic suggests, and human imagination, far from being mere fantasy, reflects deep intuition about reality's hidden structures. Cinematically, we can visualize ancient observatories, sundials, and cosmic art, connecting the past and present in a continuum of wonder and reflection. Speculative scenarios, the playful, imaginative projection of backward time, serve a dual purpose. They entertain the mind while deepening philosophical insight. Humans aging backward, civilizations unmaking themselves, and entropy reversing are not predictions, but tools for thought, narrative vehicles to explore consequence, causality, and existence. These sequences, while fantastical, echo real patterns of observation and perception, reinforcing the idea that reality is experienced as much as it is measured. By inhabiting such possibilities mentally, we expand our capacity for awe, cultivating an appreciation for the universe's complexity and the mind's imaginative power. The tension between knowledge and mystery is central. Science provides models, experiments, and equations. Speculation illuminates the spaces beyond empirical reach. Time, though measurable and manipulable in theory, retains an elusive essence, a mystery that challenges both understanding and intuition. Cinematic storytelling bridges these realms, neurons firing, galaxies spiraling, and civilizations dissolving unfold in sequences that are both visually arresting and intellectually stimulating. The narrative draws viewers to contemplate their place within a universe that is at once knowable and unknowable, ordered and paradoxical. Ultimately, the journey emphasizes that even if time does not flow backward in physical reality, contemplating it transforms consciousness. The exercise itself is revelatory. By imagining reversed sequences, we gain insight into causality, perception, and human experience. We confront the fragility of knowledge, the construction of memory, and the malleability of identity. We recognize that curiosity is a force as expansive as the cosmos, capable of propelling thought beyond immediate evidence. And that wonder is a legitimate, even essential, mode of engaging with reality. Existential reflection is inseparable from this exploration. Humanity's quest to understand time mirrors a deeper desire to comprehend the universe and our own place within it. By examining causality, consciousness, and cosmic evolution, we confront the ultimate questions. Who are we in the flow of time? How do our perceptions shape reality? What is the meaning of existence when the arrow of time is flexible, uncertain, or reversible? Cinematically, these reflections unfold across scales, intimate neural landscapes, unfolding human lives and infinite cosmic panoramas, each contributing to a profound sense of connection and perspective. In closing, we return to the opening question. What if time is flowing backward right now? While physical reality may not support such a reversal, the thought experiment itself illuminates fundamental truths. Time is a construct, both external and internal, measurable and experiential, linear in appearance, yet potentially malleable in perception. By engaging imagination alongside evidence, speculation alongside observation, we expand consciousness and cultivate awe. Cinematically, this final reflection invites viewers to see themselves within a vast narrative, a participant in an unfolding cosmos, a witness to temporal mystery, and an explorer of reality's boundless dimensions. The universe, in all its scales, remains astonishingly complex. Galaxies, stars, and black holes remind us of cosmic time. Neurons, memory, and perception reveal the intimacy of subjective experience. Both are intertwined, suggesting that understanding time requires attention to both mind and matter. The contemplation of reverse temporality, whether speculative or metaphorical, deepens this insight, reminding us that human curiosity is not merely about answers, but about the capacity to question, imagine, and reflect. Cinematically, the interplay of vast cosmic structures and intricate neural activity forms a bridge between macro and micro, exterior and interior, known and unknown. As viewers, we are invited to dwell in both awe and humility. Time, whether flowing forward, backward, or in ways yet unimagined, shapes experience, meaning, and understanding. It is the medium of existence, the canvas for consciousness, and the lens through which we interpret the universe. Reflecting upon its possible reversibility enhances appreciation for life, memory, and the cosmos itself. We glimpse the fragility of human perception and the grandeur of cosmic processes, fostering a profound emotional and intellectual engagement. Finally, let us embrace the poetic resonance of this exploration. Human curiosity drives us to look beyond immediate evidence, to imagine worlds that defy intuition, and to engage with the cosmos as participants rather than mere observers. Even as galaxies swirl, stars collapse, and neurons fire, we are connected to the vast continuum of time and consciousness. The contemplation of backward time, in speculative, philosophical, and cinematic terms, is an act of wonder, a celebration of intellect, and a meditation on existence itself. Time, perception, and consciousness remain inseparable. Each question, each speculation, each visualized reversal expands the horizon of understanding. While certainty resides in evidence, beauty resides in mystery. The human mind, endowed with imagination and curiosity, navigates these dimensions, constructing meaning from both what is known and what is imagined. Cinematically, the narrative concludes not with answers, but with resonance. The viewer is left suspended in awe, reflection, and the recognition that the quest to understand time mirrors the quest to understand ourselves. In the end, contemplating reverse time is less about chronology and more about consciousness. It is an invitation to explore, to question, to wonder, and to marvel. From neurons to galaxies, from personal experience to cosmic evolution, the journey reveals the profound interconnectedness of mind, matter, and temporality. Even if time flows only forward, the act of imagining reversal expands our perception, cultivates insight, and enriches appreciation for the universe's complexity and beauty. As the cinematic journey closes, we recognize the ongoing human endeavor to observe, to question, and to imagine. Our curiosity propels us through galaxies, neurons, and civilizations, across billions of years and infinitesimal moments, reminding us that understanding is never complete and wonder is infinite. Time, whether forward, backward, or imagined, becomes a medium for reflection, a tool for insight, and a canvas for the imagination. Through this exploration, consciousness itself is illuminated, flexible, creative, and inseparable from the temporal landscape it perceives. And so, we leave with a final meditation. The universe is vast, time is mysterious, and human curiosity is boundless. To imagine backward time is to engage in a profoundly human act, to reflect on existence, to question reality, and to marvel at the intricate, unfolding tapestry of life and cosmos. Cinematically, philosophically, and intellectually, this contemplation invites awe, nurturing both the mind and the spirit, and reminding us that even in mystery, there is beauty, connection, and profound wonder.